Welcome to this video. My name is Mark Umber, and in this video we're going to model a cap table and a distribution waterfall in Excel. The capitalization table shows the share ownership, and especially when talking about young, nascent, venture capital-backed companies, the dilution effect of subsequent funding rounds. But a cap table should reveal even more details on different classes of shares. There can be common shares, there can be preferred shares, there can be non-voting shares, convertibles, bridge loans, and more. Also, the cap table should reveal transparency on voting shares versus non-voting shares, who has invested when and how much. We use this as an outlook for future funding or even exit scenarios. In this case, the cap table is the basis for calculation of the distribution waterfall, which is very important for young entrepreneurs to understand certain cash flow rights of investors, such as liquidation preferences. Finally, cap tables have to meet legal requirements. In most countries, the company law defines how share capital is measured. Typically, a cap table shows the share capital, which is actually how the fraction of equity capital is defined in a legal way. Also, we have to distinguish between nominal value and market value of a share. The nominal value typically is the value that is registered in the company register and deviates in most cases of the market value. In Germany, for instance, the typical nominal value of one share in a limited liability company in Germany would be €1. In the US and the UK, you often see cents, and these nominal values actually define the true legal ownership distribution in the total shares outstanding. Now, the difference between the nominal value and the market value is shown in the paid-in surplus. This is the amount of money that investors actually invest in the company in excess of the nominal value of the shares. A cap table typically differentiates between these two items: the legal basis, which is measured in the nominal value, and the economic or commercial basis, which is shown in the paid-in surplus. Finally, if we use the cap table as an outlook and as a planning tool for measuring how much money will be distributed in the event of an exit, which will show how the proceeds of an exit flow into the pockets of different investors and owners according to this distribution waterfall. Now, before we go into the Excel modeling, here's a little case study. This is the case of Scalenomics. In 2013 and 2014, Hasso and Dietmar worked for IBM on customized cloud solutions for the banking industry. In February 2015, they finally decided to follow their dream of a one-size-fits-all, easy-to-implement cloud solution for banks and founded Scalenomics. The first 6 months were dominated by long working hours, numerous weekends, zero pay, and an ever-growing backlog of new ideas. After half a year of programming, Hasso and Dietmar finalized the alpha version of Cloudrefin and decided that the product was ready to enter the market. After several frustrating months of cold calling IT department heads at various banks, they finally found one mid-sized bank that showed interest. The bank was actually more interested in Hasso and Dietmar's expertise for an internal project, but they were willing to test Cloudrefin in a test environment. The project was a welcome change to the preceding months, full of deprivation and hermitage, and it helped to soothe the anger of Hasso's and Dietmar's girlfriends, who started to question the idea of how great it was to become an entrepreneur. Now, setting up a cap table in Excel starts with very basic layout questions. We will format the table in such way that the rows will show the ownership and also subsequent investments by individual shareholders. The only thing to document now is the inception of Scalenomics. We put down Hasso and Dietmar's name, and Since they founded a German limited liability company, a GmbH, the minimum required nominal capital is 25,000 euros. If we assume that Hasso and Dietmar are equal partners, each of them will hold 12,500 shares. This will be registered in the German company book, the Handelsregister. And so far it's very easy to calculate the percentage ownership, which is 50-50. Okay. Let's take away this line. Okay, this will be the start of our cap table. So far, it is not revealing much information, but it is going to become more complex. Let's take a look at the next chapter. Right from the start, the bank's internal project manager Klaus knew that they would need something scalable rather than their existing in-house solution, which always took weeks of customization effort just to change the color of a button. Klaus shared the vision of Hasso and Dietmar about the necessity for a cloud solution like Cloud Refin. But he also knew that the product did not meet all requirements, and he felt that their sales pitch was just horrible. So Klaus decided to be very open with Hasso and Dietmar about the needs and costs of the bank's daily operations to help improve Cloud Refin. Now, it didn't take them long to become friends. After finalizing the project in January 2016, Klaus decided to leave the bank and join Scalonomics. Hasso and Dietmar offered Klaus a 15% stake in the company in return for his knowledge and commitment. During the following months, Scalonomics shifted from being a two-man show with a half-ready product to being a customer-oriented company with a market-ready solution. Klaus was able to convince several financial institutions to run a proof-of-concept project with Cloud Refin, while Hasso and Dietmar kept programming functionalities to match the needs of their customers. Now, to model this team expansion, I'm going to unhide a couple of columns and rows which I prepared. So Klaus will become a member of the team of Scalonomics, and the negotiation result is that Klaus shall hold 15% of Scalonomics. Now, there are basically two ways of how to achieve this goal. One way would be that Hasso and Dietmar sell some of their shares in such way that Klaus will hold 15% of the outstanding capital of 25,000. Now, this is not how we do it. Typically, also for tax reasons, a company is going to issue new shares, and a new shareholder will sign up to acquire these shares at the nominal amount and avoid taxation issues. So, in legal terms, we're talking about a nominal financing round. Now, to answer the question of how many new shares need to be issued, we need to solve this equation. We know the negotiation result was Klaus shall hold 15%, which is going to be the fraction of the new shares created as of the total shares outstanding after the capital increase. If you rearrange this equation and solve for the number of shares outstanding, you will get 15% divided by 1 minus 15% times the number of shares outstanding before the round. This will be 4,412 new shares. Now let's check if we made any mistakes. We have total shares outstanding, which are the existing ones. We have the new shares that we created. And this will give us a total of 29,412 shares. Let's check the percentage of ownership. This will be 12,000 divided by the new amount of shares outstanding. And the sum of this is 100%. Okay. We do have to make some minor checks. Let's add this type of information. Now, according to German GmbH law, German company law, the nominal amount of shares must not be smaller than 1. So we need a natural number. Let's see. We need to round to make this a natural number. Okay. Very good. Just to make sure that we don't introduce rounding errors into our capitalization table. Let's go back to the next chapter, the seed round. Fritz Müller, a Frankfurt-based business angel who met Hasso at a startup event in fall 2015, was happily surprised when he read the bi-monthly update mail stating that Scalenomics won several POCs with local banks. So he picked up the phone to call Hasso and ask about their funding and what terms the team would have in mind. From looking at Scalenomics' financial plan, Fritz saw that his usual ticket size of 50,000 euros would not be sufficient to meet the capital needs to scale the business of Scalenomics. So he called his friend Heinz, who was working as an investment manager at Frankfurt School's venture capital fund, to persuade him to co-invest. In June 2016, Scalenomics closed their seed round of 300,000 euros fresh money at a pre-money valuation of 1.6 million and a 1x non-participating liquidation preference. To model this next step, again, I'm going to unhide a couple of columns that I prepared. And now we will have new owners entering the cap table. We will need the status quo of the company as a basis. Okay, let's start with the input data. We know that the pre-money valuation that was agreed on was 1.6 million euros. And now this is the first time where we have a market valuation. Given the amount of shares outstanding and a valuation of 1.6 million, we can easily calculate the current share price, which is the pre-money valuation divided by the number of shares outstanding, which is 54.40 euros. Again, we need to make sure that we don't introduce any rounding errors. So let's make this a real euro value. We know that Fritz, being the business angel, will want to invest 50,000 euros, and Frankfurt School Venture Capital will invest 250,000 euros. The question now is, how many shares do I get for an investment of 50,000 euros? That's just very easy. Take the 50,000 euros, divide that by the share price, and get 919 shares. Now again, we need to make sure that we're compliant with German company law. And German company law says that the lowest nominal value of a share is 1 euro. So we need to make this a natural number, which also explains why we differentiate between the target invest that an investor intends to invest, and this will slightly deviate from the actual invest, which we will calculate in the paid-in surplus. Now we know for 50,000 euros, Fritz Müller, the business angel from Frankfurt, is able to retrieve 919 of new shares, and you can use this formula to calculate how many shares Frankfurt School Venture Capital will hold, and this is 4,596 shares. This is all the new shares that are created, during this round. We have, let's add just for completion some of the sums. We also know that there are already common shares outstanding, and this is the first time where we will separate between the newly created preference shares for seed investors, because we call them preference shares because holders of these shares have a non-participating liquidation preference. Common shareholders do not have this right. This clean, just to finalize everything. And now it becomes interesting to see how much in excess of paying the nominal value do the investors have to pay as a paid-in surplus. Now, according to German company law, Fritz Müller and Frankfurt School Venture Capital have to pay the nominal amount in euros to the bank account of the company to actually sign up for these shares. This is the legal transaction behind taking ownership of these new shares. So we now need to calculate the amount that is left in excess of already paying 919 euros to the paid-in surplus. This is equal to 919 times the share price. But since business angel Fritz Müller already has to pay 919, we have to subtract 919 of that. We can achieve that simply by having 919 times the share price minus 1 times the share price. And this is the actual amount that goes into the paid-in surplus. Let's make this a euro value again. And we can copy and paste this formula. The same is true for Frankfurt School Venture Capital. They pay 4,596 euros in a separate legal transactions simply to pay for the nominal amount. And in addition, they have to wire transfer the paid-in surplus of 245,426 euros. And now you see there will be a slight difference between the target investment of around 250,000 and the actual sum, which is the value that will be also put down in the financial contract of the financing round. So Fritz Müller, the business angel, pays 49,994 euros, and Frankfurt School slightly above 250,000. It's 250,022. Okay, let's make this table complete. Now we can calculate the total number of shares outstanding, which is the common shares plus the newly created shares. Make this nice. Take away these. Always try to make your table as transparent and comprehensible as possible. So after this transaction, Scalonomic will have shares in the amount of 34,927 outstanding. Now always check if you make rounding errors. Look at the number of digits behind the decimal. These numbers, every time we talk about nominal shares, these have to be natural numbers. Okay. You can calculate the ownership of all shareholders. Let's clean up here and check whether this is all correct, and we have 100%. And now we see for the first time the dilution effect for the existing management and founders. Before this financing round, Hasso held 42.5% of the company. After the funding round, Hasso holds 35.8% of Scalonomics. And overall, the new shareholders in total hold 15.8% of Scalonomics for an investment of 300,000 euros. roughly. Let's look at the next chapter. In fall 2017, which is 14 months after their seed round, Hasumi had mixed feelings about the future. Although they had achieved quite a bit, raising their Series A proved to be much tougher than expected. During the last year, Scalenomics won a couple of new customers and almost doubled their revenues. In addition, after several major releases, CloudRiffin had so many more functionalities and was much more stable. Still, investors were hesitant and the fundraising progress was very slow. As a consequence, Hasu needed to take action and try to convince his investors to extend the cash runway for the firm by an additional investment of at least 200,000 euros, and this will help to build the traction necessary to convince Series A investors. In the end, all shareholders came to an agreement to accept a convertible loan of 250,000 euros from Frankfurt School Ventures at 8% interest and a discount of 20% to bridge this gap. After several months of steady growth and numerous talks to VCs all over Europe, in July 2019, London-based Unicorn Capital decided to invest 2 million euros and Frankfurt School Ventures an additional 500,000 euros on a valuation of 10 million and a 1.5x participating liquidation preference. Now let's take a look how these two steps in the future funding of Scalenomics will look in our cap table. Gonna expand. In the first step, we need to model the bridge loan that is provided by Frankfurt School Ventures in the amount of 250,000 euros. We know this loan has 8% interest with a 20% discount to the share price of the next funding round. And let's assume that that the payout date of this loan was January 15, 2018. This will help us to calculate interest days for future modeling. Now, we could easily now use the row where we have Frankfurt School as an owner in this cap table and model all subsequent funding of Frankfurt School in this one row. This is not how I do it. I prefer to see all legal transactions in a separate row and then have full transparency on every single step along the life cycle of this company. So I'm going to add another row for the bridge to Series A of Frankfurt School. Let's put down the 250,000 euros here. In total, very straightforward, 200,000 euros. That is the first step. This is basically it for the bridge loan, just to document all the necessary commercial terms. Now comes the next step. As a next step, we're going to introduce Unicorn Capital on the cap table. We will have an additional investment by Frankfurt School of 500,000, and we will convert the loan that was given, the bridge loan that was provided by Frankfurt School, at a discount share price. Now, the shareholders of Scalenomics and Unicorn Capital agreed on a pre-money valuation of 10 million euros. This gives us the necessary information to calculate the share price, which is the pre-money valuation of 10 million, divided by the number of shares outstanding before this round. This is 286 euros and 31 cents. Now again, make sure that we avoid rounding errors. So let's take 2 digits after the decimal. And to be able to calculate the loan amount that is to be converted into this bridge, we also need to know when is the last day of interest payments for calculating the accrued interest. Now let's assume, since the financing round takes place in July 2019, let's assume this was July 15th, 2019. And let's put down the numbers. Unicorn Capital intends to invest 2 million. Frankfurt School Venture Capital invests another 500,000. And they will also convert the loan outstanding, including the accrued interest, but at a discount share price. Let's start with the fresh equity investments, since they are much more straightforward. We want to invest 2 million at a share price of 286 euros and 31 cents. And we need to make sure that this is a natural number. Let's also make sure that we can copy and paste this formula. So Unicorn Capital will sign up for new shares in the amount of 6,985. Frankfurt School Venture Capital will get new shares in the amount of 1,746 for the new 500,000 fresh money investment. Now comes the more interesting part. First, we need to calculate how much interest was accrued. We know that the nominal amount is 250,000 euros times 1 plus the interest rate to the power of. We take the days between call date and payout date and divide that by 360. This is by convention, and this will most typically be documented in the contract how interest days are going to be calculated. We assume a total amount of days per year of 360. Okay, this should be it. Nominal amount. Let's add some brackets. Okay, very good. Again, we need to make sure that we don't make any rounding errors. So this gives Frankfurt School a total loan conversion value of 280,952 euros and 37 cents. Now for this, we would get, if we follow our logic, we would get a number of shares, but now on this loan conversion, we get a discount share price, a discount of 20%, which we have to take into account, times 1 minus the 20%. This is the actual share price that Frankfurt School will get on the conversion of its bridge loan. That would be 1,226. And again, we need to make this a natural number, no digits after the decimal. So Frankfurt School will get 1,227 shares for the loan conversion. And to highlight that this is a loan conversion, we're going to do this in light gray and italic, such that we see that this was not an inflow of fresh money, as opposed to the investment of 500,000 from Frankfurt School and 2 million of Unicorn Capital. Let's make the rest for completion. Okay, so this is the new share class of Series A shares. We will call them preference shares, because it comes with certain investor rights, such as now a 1.5x liquidation preference, which is different from the old seed shares that already had a liquidation preference, but only 1x. Okay, let's assemble the table. We have old Series A shares. These are the seed investors. Frankfurt School now holds seed shares, seed preference shares, and Series A preference shares. And we have the old common shareholders. Okay, Hasso Dietmar, Klaus, here we have Fritz Müller, Frankfurt School seed shares, Frankfurt School conversion A shares, Frankfurt School Fresh Money A shares, Unicam Capital Fresh Money A shares. Let's make this complete. So now is the time to calculate the paid in surplus. We take the number of shares that Unicorn Capital already paid 6,985 euros for, which is the nominal value, times the share price minus 1, which is 1.992 million euros. Now in total, this is the amount that Unicorn Capital actually invests in Scalenomics in this financing round, which is the sum of the nominal shares, which have to be paid is in euros, plus the paid in surplus. The smallest unit of calculation in any cap table is the share price. And this is the reason why there are deviations between a target investment sum and the actual investment sum that an investor will make into the company. Okay, let's take this formula. Same is true for Frankfurt School. Let's see. Overall, in sum of the nominal amount and the paid in surplus, Frankfurt School invests 499,897 euros. We have new shares from the loan conversion. Now this is a bit more tricky because we have, if we simply calculate the paid in surplus in the same way, we would end up with a value that is simply too high. This would be way higher than the loan amount that is outstanding that is to be converted into equity. Why is that? Because we had a discount share price. So we need to take 1,227 shares times our preference share price. And the preference share price was 286 times 1 minus 20%. This is the discount share price. And we need to subtract 1 because Frankfurt School will have to pay the 1,227 euros in cash. This is a very peculiar thing about German company law. If you do not put this transaction on record, which means Frankfurt School wiring 1,227 euros to accept the nominal amount of shares, then this transaction would legally not have happened. So they have to pay the 1,227 in cash. The rest can be offset with the loan amount outstanding. Now let's check our formula. This looks very good. So overall, we have 281,042. So there will be a slight difference, between the loan conversion. Now, there's two ways of how to deal with this in practice. One way would be simply to ignore that. This is from a tax perspective, this would not be according to German law. Another way to be safe from paying extra money after conversion of loan outstanding would be to round down, which would give us 1 share less from 1,227 to 1,226. Now the sum of this would be equal to 280,813, which is slightly less than the total loan amount. And the difference can be paid back by Scalenomics to Frankfurt School Ventures. So there will always be slight differences between any target amount that is either paid in cash or converted into new shares. And there are separate ways of how you can deal with this in practice. Here we use the way of rounding down, such that we do not have a discrepancy between the total loan amount outstanding and the total amount that flows into Scalenomics. Okay, very good. Let's make this cap table complete. Now we want to know how many shares are actually outstanding across all share classes. Let's make this nice and readable. Take away the let's check whether we had any rounding errors. No rounding errors. And now we can calculate the ownership of various shareholders. Again, let's have this very transparent and comprehensible. And let's check whether we made any errors. 100%. Very good. Okay. Let's take a look at the dilution. Before the financing round, before Series A, the founders and the managers held 84.2%. After the Series A, managers and founders hold 65.5%. Also, we see that the business angel, Fritz Müller, now dilutes from 2.6% to 2.2%. And Frankfurt School now holds a total of 16.9%. And you see that Frankfurt School, who participated in both the seed round, the bridge to the Series A, and the Series A, now holds different share classes. Okay. Let's take a look at the next chapter. In November 2021, which is 29 months after their Series A, Scalenomics had won many clients throughout Europe and became a known provider for cloud solutions for financial institutions. However, competition became fierce, the prices dropped, and future growth proved to be difficult. While revenues in 2020 were at 25 million euros, Hasso expected to hit only 24.3 million euros in 2021, which is 20% below what he had hoped for. In addition, Amazon Web Services was working on a tailor-made solution for banks, which was expected to be released in 2021. After time-consuming discussions, all shareholders came to the agreement to try and sell Scalenomics to either a large incumbent, for instance IBM, or to one of its better-funded competitors in the US. Now, knowing that large corporations usually pay significantly less for companies that are not break-even, Hasso carefully crunched the numbers and convinced his investors to invest another 1.5 million euros to reach break-even by January 2023. Through a convertible loan at 8% interest, a 20% discount, and an exit kicker of 30% in case of an exit. Let's take a look how this will change our cap table. And as before, there are two steps along the way. The first one is the bridge loan, and this bridge loan now is provided by Frankfurt School and Unicorn in the amount of 1.5 million. Now, Frankfurt School and Unicorn Capital will split the total loan amount of 1.5 million on a pro rata basis. Pro rata means that the split is according to the relative holdings of these individual investors, which is the sum of the shareholdings of Frankfurt School divided by the sum of the shareholdings of Frankfurt School and Unicorn Capital. So Frankfurt School will make 52% of this 1.5 million times 1.5 million. To avoid rounding numbers, we will make this a euro value, and the same is true. Here we can simply take this divided by the sum of the shareholdings of Frankfurt School and Unicorn Capital. So in total, let's always check whether this sums up. Yes. This is the pro rata base of the 1.5 million in bridge loan. And we must not forget to put in the other very important inputs, 8% interest, 20% discount in case of a subsequent funding round, and a 30% exit kicker in case of an exit. And again, we need to make an assumption about the payout date such that we can calculate the interest payments for the next funding round or for the exit. Now, since we are now venturing into this exit, shareholders usually want to know, in case of an exit, how will the proceeds of this exit turn out to materialize in the pockets of every investor? For this, we need the waterfall distribution, and we know that there are certain share classes with liquidation preferences, which means with certain cash flow rights to individual investors. Now, by law, typically the first tier of any waterfall distribution will be the debt outstanding. Debt comes always before equity, and we know that there's an exit kicker that was agreed on when they provided the bridge to exit. To calculate the total amount outstanding on this loan, including interest and exit, we need to make an assumption on the call date. Now, since we know from the case study that Scalenomics is to reach break-even in January 2023, and if we assume another 6 months of negotiation and finding an acquirer, let's assume that the call date of this loan will be 15th of July in 2023. With this information, we can calculate now how much the accrued interest will be, number of days to calculate the interests divided by 360. This is the accrued interest plus the nominal amount. And now we add the exit kicker, 1 plus 30%, which will be 1.1 million euros. Let's see. Let's make this such a way that we can copy and paste the formula. Let's test the formula. Very good. So in total, the first tier of our waterfall distribution will hold 2.191 million euros that can be redistributed. Now, let's make an assumption that we have a bit more than 1 times the annual revenue that Scalenomics will provide, just for starters. And this would be a round number. Let's take 30 million euros. Now we can calculate how much money every individual investor on every tier of the waterfall distribution will retrieve. For this first tier, it will be either a maximum of 1.139 million euros for Frankfurt School or less, and this will be split on a pro rata basis. Typically, the split is pro rata according to the tier of the waterfall distribution. So Frankfurt School will be eligible for slightly more than 50% on this tier, and Unicorn Capital will retrieve slightly less than 50% on this tier if there's not enough money on the table. So we have to use a minimum function, because the money that Frankfurt School will get on this tier of the waterfall distribution will either be 1.139 million, or it will be what's to be distributed times the fraction, the pro rata fraction on this tier. Fix this. That. Okay, this looks good. Now let's test our formula, because we cannot distribute more on this tier of the waterfall distribution than the cash flow rights. So if we only have 2 million on the table, we need to split this money on the pro rata basis, and this is exactly what our formula does. Very good. Always try to test your formulas such that they work. Okay, this is the first tier, meaning the debt capital on the waterfall distribution. The next step is the tier 2, where we deal with the Series A preference shares. And these preference shares come with a participating liquidation preference at 1.5x. So a factor of 1.5 on the total money invested during the Series A shares as a preference amount. The first step is to gather the volume that is in this preference. For Frankfurt School, this will be the total sum of all nominal amounts plus the paid-in surplus, which for the fresh money in Series A was almost 500,000, and the loan conversion of almost 280,000 euros. Okay, same we do for Unicorn Capital, Series A. The sum of nominal amount and paid-in surplus. And we must not forget about the factor of 1.5 on this money. Let's take this factor. Receiving a total volume in this tier 2 of 4.17 million. Before we model how much cash every shareholder will get, we need to know how much money is left on the table. So we have an estimate of 30 million total proceeds from the exit. We already distributed 2.19 million on the tier 1. So there's 27 million left on the table. The commercial aspect of the participating liquidation preference means that Frankfurt School is entitled to receive up to 1.17 million euros before any other cash flows are dealt with in later tiers of the waterfall distribution. It's either the maximum of full 1.17 euros, or if there's not enough money left on the table, a fraction of that money split according to the relative weights in this tier 2 liquidation preference. And we're going to model this as a minimum function. It's either the maximum of 1.17, or it's what's left on the table times the fraction of preferential rights in this tier of the waterfall distribution. Let's take this formula, copy, and now we need to check whether our formulas do what we need them to do. So if there's not enough money on the table, we know that on the first tier there's already 2.1 million redistributed, and there's another 4 million to be redistributed in the second tier. If we would only receive 4 million in total proceeds for the exit, this would not leave enough money on the table to fulfill all cash flow rights on tier 2, and then our formula splits the money that is available according to the relative weight, according to the pro rata in the tier 2. Very good. Always make sure you test and challenge the formulas that you built. Very good. Now let's move over to the tier 3, The first question is how much money is left on the table. And the tier 3 is the preferred shares of seed investors. And the preference shares of the seed investors came with a non-participating liquidation preference with a factor of 1.0. A 1x non-participating liquidation preference means that investors will receive their money 1 times their money invested in the seed stage, but if there's more money to be redistributed on later tiers in the waterfall distribution, every euro will be offset with euros paid in later tiers. And we will see what this means in a minute. First, we have to assemble the total volume that is in this preference. So we go in our seed cap table. That's 50,000 for Fritz Müller and 250,000 roughly for Frankfurt School. It's a 1x. So I could simply skip this step, but for transparency, I want to multiply this with the factor of 1. That way we could even play around with different factors and see how this changes the waterfall distribution. In sum, we have 300,016 euros on this liquidation preference tier. Now we will start modeling this non-participating liquidation preference in a similar way to how we dealt with the participating liquidation preference, and then we will use circular reference and the built-in numerical functions of Excel to solve our problem. In my opinion, this is the easiest and one of the most transparent ways of modeling non-participating liquidation preferences. And we will see how this works in a minute. So we will start in the very same manner as we modeled the participating liquidation preference. So it's Fritz Müller receiving either a maximum of 49,994 or what's left on the table times the relative weight of cash flow rights in this third tier of the waterfall distribution. Okay, let's copy this here, test whether all the references hold, add the sum so we see that everything adds up. Okay, again, the next step should be to test our formula. So as a first step, we want to see how much LP volume is in tier 1 to 3, which is the sum of 300,000, 4.1 million, 2.19 million, which is 6.6 million euros. And we see if we have only 6.6 million on the table, this is just enough money to pay out the first 3 liquidation preferences. If we only have 6.5 million on the table, this will not be enough money to pay out tier 3 liquidation preference holders, and our formula splits the amount in a pro rata way. Very good. Okay, let's go back to our 30 million. And we're not done yet. This is why I highlight these 2 cells, because we need to come back and introduce this circular referencing to make this currently participating liquidation preference into a non-participating liquidation preference. So hold on, we will come back to this in a minute. See how much money is on the table to be redistributed in tier 4, and tier 4 is already our last tier in the waterfall distribution. This is where the actual ownership comes into play. So the fraction every shareholder holds in Scalenomics Let's clean up. Let's test whether we have 100%. Very good. And on the pro rata stage, it's simply what's the money left on the table multiplied with the relative shareholdings times this, and let's check. Okay, every euro has been redistributed now. And if this was a participating liquidation preference, we would be done. But now we need to change these formulas to make the participating liquidation preference formula become a non-participating liquidation preference formula. And for this, we simply want to offset every euro that has been paid on the pro rata stage with a euro paid on the third tier for seed share preference holders. And this is where we introduce this circular reference, because we were going to simply subtract the amount that is paid on the tier after the non-participating liquidation preference. And this will result in a highly negative number. Since we have 30 million of exit proceeds and there's still 23 million in proceeds to be redistributed on the pro rata stage, there's ample money. We only need to offset up to 50,000 euros for Fritz Müller. So we need to introduce a boundary. And we're going to do this with a maximum function. So it's either offsetting all the preference amount on tier 3 with the euros received on the pro rata. And once this turns negative, it's going to be 0 euros on the tier 3. Let's see. Copy this formula. And it's very important to understand this circularity. Now, the outcome of this formula is also an input into cell AT16, which is back referencing to this formula. This is the circularity. And if you did not activate circular referencing in Excel options, then you will get an error message. Okay, let's again test whether these two formulas give the right results. Let's see how much Fritz and FS Venture Capital will receive as a sum on both of these tiers. Now, if we have enough cash on the table to offset all the euros in the third tier, let's go to the edge cases where there's hardly enough money on the table to fulfill all the pro rata. And we know that we had a tipping point at 6.6 million where we fulfill all the first tiers in the waterfall distribution. This is where our formulas give us the maximum of the preference amount. And once we move over this tipping point, we want to see that our non-participating liquidation preference is now offsetting with euros received on the next tier, which is the tier 4 pro rata stage. And we see that the sum of the tier 3 and the tier 4 for Fritz Müller will always be equal to his preference amount of the seed shares until we reach the next tipping point where every euro on this non-participating liquidation preference has been offset. As we move up, we see how the amount that is distributed on the tier 3 gets offset with the amount distributed on the pro rata, and the sum is always equal to the preference amount. With 8.7 million, we're almost at the tipping point where all the euros have been offset for Fritz Müller. Once we reach 9 million, you see that all euros have been offset, and this is the point where also the sum of the cash that Fritz Müller receives on the pro rata and the tier 3, which then will be always 0, will increase. So for any shareholder who holds a non-participating liquidation preference, there will be a plateau where this shareholder will receive the same amount of money, be it, in this case, exit proceeds in the amount of 6.7 million or 8.7 million. Fritz Müller will be on this plateau until all the euros have been offset. So not until we reach 9 million, then this overall proceeds will rise for Fritz Müller. This is the very nature of a non-participating liquidation preference. Okay, let's reset to our initial estimate and let's clean up. And we're almost done. Now is the time where we want to know how much total proceeds each shareholder gets. For Fritz Müller, we need to have the sum of these two. For Frankfurt School, we want to have the sum of all of these 4 rows. And Unicorn Capital Partners will be the sum of this, 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 this. Now let's check if we made any mistakes. This has to add up to the total proceeds of the transaction, and it does, 30 million, very good. Now we can calculate the fraction of the total proceeds for every shareholder. %. And we see for Hasso, for instance, Hasso is a common shareholder, the founder and owner. He receives 21.9% of total proceeds, although he's holding 27.8% of Scalenomics. This is due to the fact of the liquidation preferences that end up in the waterfall distribution and introduce distortions to the cash flows. Now, for investors, it is very interesting to see the ratio between how much they receive back in distributions and how much they initially invested. And now we can simply use the way we set up our table. Fritz Müller only was participating in the seed round. Frankfurt School invested. Let's start with the beginning. It started with the seed round, 250. It did invest another 280 in loan conversion, another 500,000 fresh money in the Series A, and another 780,000 euros in the bridge to the exit. In total, this is 1.8 million investment by Frankfurt School. Let's take a look at Unicorn Capital. Unicorn joined Scalenomics in the Series A with 2 million invests. and another bridge investment of 719,000 in the bridge to exit. So total invest of 2.7. Scalenomics had a total fundraising of external money of 4.58 million. And now we can calculate the multiples of the investors. This is the interesting moment we've been waiting to see. And let's make these bold. And we see that Unicorn Capital Partners, given an assumed exit of 30 million, made a multiple of 2.84. Frankfurt School, being a seed and Series A investor, had a multiple of 3.48, and the best deal was for Fritz Müller, who had a multiple of 9.68. And now we can play around with different scenarios. If we assume that we can sell Scalenomics at roughly 2 times the 12-month revenue, and if we assume that Scalenomics will still make 25 million over 12 months in revenue, this would give us 50 million estimate. So this would only be a 2x revenue multiple. This is not too aggressive. And we now see that Frankfurt School would make an investment multiple of 5.34, and Unicorn Capital would have made an investment multiple of 3.99. That is an okay multiple. For venture capital, this is an okay multiple. Okay, let's take a look at our entire table. We started with inception, had several financing rounds, bridge loans, Series A, bridge to exit, our waterfall distribution, and finally our distributions over paid-in multiple. I hope you enjoyed this video. Feel free to leave any comments. Thank you very much.